Hi YouTube, good afternoon. Welcome to another video on basic mathematics for secondary 3 and 4 students taking the Singapore GCO, NA and NT exams. This video is on the introduction to Trigo and its applications. This video is useful for all streams, normal academic, normal technical, as well as express students. So what this video will cover, it will cover the applications of trigo ratios to right-angled triangles. This is a basic video, therefore we will only look at right-angled triangles today. Okay, so let's begin very quickly. This is a right-angled triangle. Okay, I'm going to use the Pythagorean triplets 3, 4, and 5 because they are simple to remember and they are simple to use. But this will work with any Pythagorean numbers. Okay, so the thing is, those of you who are still struggling with what I mean by Pythagorean triples, could you please visit either Google it, or you can, there's a video that I did just about a couple of days ago that explains to you what Pythagoras theorem is. Alright, okay, so assume that there's a theta over here. Okay, theta once again is an acute angle. Okay, and then you are asked to find the ratio cosine theta. Now, when you're asked to find cosine theta this way, you're basically asked to find what is the cosine ratio when we refer to the angle theta. Okay, so when we know that cosine theta is the cosine ratio is adjacent over hypotenuse, where your adjacent is over here. Okay, your hypotenuse is over here, and your opposite side is over here. So if you are still wondering why did I label this this way, you can check out my other video on the introduction to Trigo, which will explain why do I label the sides this way. Okay, so cosine theta is basically your adjacent over hypotenuse. In this case, your adjacent is 3 and the hypotenuse is 5. Okay, so now this is basically, we are done. When we are asked to look for cosine theta, we are asked to look for the ratio that's associated with the reference angle theta. So cosine theta in this case is 3 over 5. Carrying on, if you are asked to find sine theta, the sine ratio is opposite over hypotenuse. Okay, so in this case, the opposite of angle theta is 4, the hypotenuse is 5, and then you are done. Okay, lastly, tangent theta. Okay, tangent theta is the opposite, the ratio is opposite over adjacent. Okay, the opposite is 4, the adjacent is 3, and here you go. So if you're asked to look for cosine theta, sine theta, or tangent theta, you're basically asked to look for the ratio, the specific trigo ratio that's associated with the reference angle theta. Okay, next. If once again, if this is a right-angled triangle, the right angle is here, and you're given theta over here, okay, and then you are given this, where 3 here is your adjacent again, 4 is your opposite side, and this side is the hypotenuse. Okay, so right now, this is a right angle triangle with the given sides. Once again, I'm using the numbers 3, 4 just because they're easy to use. This will work with any other numbers, assuming this is a right angle. Okay, now, so if let's say we start with tangent theta, there's no problem because tangent theta is opposite over adjacent, okay, which is 4/3. Okay, now the problem arises when you're asked to look for cosine theta and sine theta. The reason is because cosine theta is adjacent over hypotenuse, and sine theta is opposite over hypotenuse. Now, we realize that the hypotenuse is unknown. Now, since this is the basic introduction to Trigo, we are working with right-angled triangles. And the thing about right-angled triangles is it allows us to use a Pythagoras theorem to find different sides if we are given at least 2 other sides. Okay, so in this case, we are given the adjacent, we are given the opposite. Okay, we can just label this A for reference, and then this side is B. okay, and the hypotenuse we label as C, okay. And by the Pythagoras theorem, we know that a squared plus b squared equals to c squared, okay, where a squared is 3 squared plus b squared is 4 squared equals to c squared. 3 squared is 9, 14, 4 squared is 16, c squared. 25 equals to c squared. Square it both sides. Okay, and then therefore c equals to 5. Okay, so that we have found the unknown side. So once we have known the unknown side, we can just use what we've done so far, 3 over 5, and then opposite is 4 over 5. Now, once again, I'm only using the Pythagorean triplets, 3, 4, and 5, because they are convenient to use. Okay, once you have a right angle triangle, you can just apply the Pythagoras theorem to look for unknown sides if you are given at least 2 other sides. Okay, so if you need revision on Pythagoras theorem, once again, there's a video already done on Pythagoras theorem, so please check that out to revise on how you can find the unknown side using Pythagoras theorem in a right angled triangle. Okay, now next thing is you are asked to look for the angles. Now this is slightly different. Previously you were asked to look for ratios, for example sine theta, cosine theta, and tangent theta. Now when we're asked to look for angles, we are looking for theta, just theta, not the ratios. Okay, so once again, you are asked to find what is the angle theta. Okay, so in this case, we have a right angled triangle with sides 3, 4, and 5. Okay, so we see that sine theta, okay, is opposite over hypotenuse, 4/5. Now, this is a sine ratio associated with the angle theta. So if let's say we want to find what theta is, we need to do the inverse of the ratio, okay, which is represented by theta, okay, equals to sine inverse, the inverse of sine, 4/5. Okay, and if you can put that in your calculator, if I can bring my scientific calculator up, okay, you can see there's an inverse sine, okay, 4/5. Okay, make sure your calculator is in degree mode, okay, and in sine inverse 4/5 is 53.13. Now for angles, we usually leave it to 1 decimal place. Okay, so we are 53.1. Okay, 53.1 degrees. Okay, now the same thing happens for cosine theta and tangent theta. Let's bring you through it. Cosine theta is adjacent over hypotenuse. Okay, now theta, you want to find theta, so you just take the inverse of the cosine of 3/5, you get 53.1 degrees as well. Tangent theta is opposite over adjacent, 4/3. Theta is tangent inverse 4/3, which will give you 53.1 degrees as well. Now, the reason for us getting the same answer for theta is very simple. Notice that the reference angle theta remains the same for all the trigo ratios that we have calculated. So if the reference angle is the same for all the trigo ratios that we have calculated, it only makes sense that theta we will get the same answer for theta. Okay, so now most students think that sine theta equals to sine times theta. Now this is wrong. Okay, now sine theta is not sine times theta. Okay, as I said before, it is sine theta is an indication, it's a notation that requires us to find the ratio, the sine ratio associated with theta. Okay, so you can't do this. Sine theta equals to 4/5. Okay, theta equals to 4/5 over sine. Okay, no, you can't do this. What is this is not a multiplication, it is an annotation that requires us to look for the sine ratio associated with theta. Okay, so please bear that in mind. Now, for example, if you are asked to look for the angle theta, you have a right angle here, okay, and you are given 4 and 5 here. Now, many students would given the information, there's a right angle triangle with 4 and 5 with 2 known sides, and then they will ask to find opposite over adjacent. Okay, sorry, sine theta. You are asked to find theta. Okay, so if you are given this information, you have to ask yourself, what sides are you given first? The first side you are given is the hypotenuse. The second side that you're given is the opposite. Now, using your knowledge of the ratios, you have opposite and hypotenuse. The trigo ratio that should come to mind is sine. Because sine theta is basically opposite over hypotenuse. You should get 4/5. And then to find theta, you take a sine inverse of 4/5. Okay? Now, if, for example, you are given, this information, where you are given the adjacent, you are given the hypotenuse. Now, there's no need for you to look for the opposite side because through Pythagoras theorem, because you already can use a trigo ratio available to look for theta. You're given adjacent, you're given hypotenuse. So the trigo ratio that's available to us is cosine theta. Because cosine theta is adjacent over hypotenuse, which gives you 3/5. And you find theta is the inverse of cosine 3/5, which will give you the same answer as this, which is 51.3, if I'm not wrong. Okay, so what I'm trying to get at is we need to know what the trigo ratios are, and using the information given, we need to select the right trigo ratio without wasting too much effort. Although the right angle triangle is given to us, we do not need to find all the sides if, let's say, we are familiar with the trigo ratios. Okay, so what have we learned today? We have learned how to find the ratios using trigonometry, basic trigo identities. We have learned to find the ratios if we are given unknown sides using the Pythagoras theorem as a way to find out the unknown side. We have learned about how do we look for the angles and what's the difference between a trigo ratio as well as an angle. And finally, we have learned about deciding which trigo ratio to use given the information available to us in the questions. So I think that's enough for today. Once again, I do this to help my students. If you find these videos useful, I would appreciate your feedback on how I can make these videos better and how I can make these videos more useful for students in secondary schools, especially in Singapore. Okay, thank you very much, YouTube. Take care and have a good holidays, everyone in Singapore.